Is another back titration question. Back titration question, we are talking about a situation where you have got two reactions, right? So now, what do you need to do? You identify the substance that is repeating itself. The substance that is repeating itself on the reactant side is going to be your excess reactant. Now, an excess reactant has got the initial number of moles, it has got a reacted number of moles, and it has got unreacted number of moles. Now, the reactant, now, in reaction 1, you're going to calculate now the number of moles in reaction 1. Now, this number of moles in reaction 1 will be the initial number of moles. Then you're going to calculate the number of moles in reaction 2. And this number of moles will be the final number of moles, or what we call unreacted number of moles. They are unreacted number of moles, or the final number of moles. Okay, then now what you do now, you subtract those two number of moles. You say, right, you now get what we call reacted number of moles by saying initial number of moles minus final number of moles. Then after doing this, after getting the reacted number of moles, now you're going to do ratio. You're going to say the ratio, in this case, you're going to do the ratio of the metal carbonate is to HBr, which is our repeating substance, or the excess reactant in this case. Now you do the whatever ratio for reaction 1 is to 2, right? Then in this case, it means the aim is to get the number of moles of this metal carbonate. You get the number of moles of this metal carbonate. After getting the number of moles of this metal carbonate, now you get the mass of the metal carbonate by using, N is equals to M over M. Then, and then you do the calculations. The aim here, you're going to, we want to identify this metal. So the aim is to calculate the molar mass of this substance. So at the end of the day, we must be able to calculate what the molar mass is. The molar mass is. Right, so let's get into it and see. Okay, first of all, I want the number of moles in reaction 1. What am I given? For this substance, I am given 100 cubic centimeters, which is my volume. We're given 100 cubic centimeters volume, and we are also given the concentration, which is 0.5 mole per cubic decimeter. Right, so using that information, I can get the number of moles. But now, if my volume is 100 cubic centimeters, it must be measured in decimeters. So I'm going to say, right, since the volume is in cubic decimeters, is in cubic centimeters, I must divide this by 1,000. So that is 0.1 cubic decimeter. Right, so now we are going to get the initial number of moles of HBr. Right, the initial number of moles of HBr, we will get them by saying concentration is equals to number of moles divided by volume. And the concentration that we have is 0.5. The number of moles, volume is 0.1. Then you'll get number of moles is equals to 0.05 moles of HBr. And these are actually initial number of moles. Right? They are initial NI. Right now, I come here in reaction 2. When I look at the reaction 2, I am given the number of moles of the substance here. Then this substance here, I'm given a volume of 20 centimeters. For this substance, I'm given a concentration of 0.2. Alright, so I'm going to calculate that the number of moles there. So for NaOH, because in reaction 2, I don't have the number of moles of HBr in reaction 2. So I'm going to use the number of moles of NaOH. I'm going to use this number of moles, the number of moles of this, to get the number of moles of HBr in this reaction 2. So we're going to say, right, concentration is equal to number of moles divided by volume. But the volume was 20 cubic centimeters, right? So you divide it by what? By 1,000. So that is 0.02. And we get an answer of 0.02. So now for concentration, already for concentration we have 0.2. Then for volume we've got 0.02. You multiply these two, you get 0.004 moles of NaOH. Right, let me continue in the next page. So initial number of moles for this, for initial number of moles we got this. Then now we also got the number of moles of NaOH, which is that. Now I'm going to use a ratio here to get the number of moles there, to get the number of moles of HBr. Alright, so I'm going to do a ratio. So the ratio of this substance to this substance. So what is the ratio? It's 1:1. The ratio is 1:1. So this is 1, this is 1. So say HBr is to NaOH, okay? The ratio is 1:1. Now, I don't know the number of moles of HBr in reaction 2. We are addressing reaction 2. So this is happening in reaction what? Reaction 2. This is reaction 2. Now, but the number of moles of NaOH, sodium hydroxide, the number of moles is that. Cross multiply. Or you can see 1:1 means the number of moles will be the same. Right? So the number of moles is equals to 0.004 moles of HBr. And this number of moles are the final number of moles, or what we call unreacted number of moles. Unreacted number of moles. They are unreacted. Now, right, to get now the reacted number of moles, you say N is equals to the initial number of moles minus the final number of moles. And this is for what? For HBr, right? So in other words, you say initial number of moles of HBr minus the final number of moles of HBr. There. So now, when we subtract these two, what is it that we get? Let's see. Right, initial number of moles was 0.05, right, minus 0.004, and this gives us 0.046 mole of HBr that reacted. Now I'm going to use the reacted number of moles. I'm going to use the reacted number of moles in a ratio to get now the number of moles of this substance here. To get the number of moles, that's the metal carbonate. Since now I got the reacted number of moles. So we got this number of moles. So we have initial number of moles of HBr. We have got the reacted number of moles of HBr, and we have got the final number of moles of HBr. Out of these three number of moles of HBr, the number of moles that you can use in a ratio to get information about another substance are the reacted number of moles of HBr, because HBr is in excess, right? Now, you can only use the reacted number of moles in a ratio to get the number of moles of the other substance. So now the aim is to get the number of moles of this, right? After getting the number of moles, I go and get molar mass of this substance so that I can identify the name of the substance or the name of the element. So now I'm going to say this metal carbonate is to, now we get there, we find the ratio between these two, right? So the number of moles now, it will be, you cross multiply them, so you'll get the number of moles of this substance being there, right? They are half of that, right? So now after getting the number of moles, I must get the molar mass of the substance. Let's get them. So we say number of moles is equals to mass over molar mass. The number of moles is 0.023. The mass of the substance we were given This was the mass of the substance that was given. 2.484 is the mass that was given to us. So we are going to say, write 2.484 over the molar mass. So if you solve here, you're going to get a molar mass that is equals to 108 grams per mole. Right? But now you want to get the molar mass of X then. So to get there, you say, okay, for this substance I've got 2x element X plus carbon plus 3 oxygens, and it must give me 108. Now for 2x I do not know. Carbon, the molar mass is 12. The molar mass of oxygen is 16, is equals to 108. So right then, let me check in the next slide. Okay, let me just find it here. Get it there. So now this is 2x plus 60 is equals to 108. And 2x is equals to 108 minus 60, which is 48. 2x. Divide by 2, divide by 2. Then x is equals to 24 grams. 24 grams per mole. Right? Then now we check an element that has got a molar mass of 24 in the periodic table. A substance with a molar mass of 24 is magnesium. Right? So therefore, it means that element there. So element X is Mg. Magnesium. Then, so to summarize what we just did is, first of all, I identified the repeating substance, right? The repeating substance. In this case, it was HBr. Okay. Then I found the number. I went to reaction 1. I found the number of moles of HBr, and those will be the initial number of moles. Then I went to reaction 2. I got the number of moles of HBr again. Of course, not directly, but by first finding the number of moles of NaOH, which is sodium hydroxide, then use a ratio to get there. That is for reaction number 2. Right? Then I said now the reacted number of moles reacted. I went on to find the number of moles reacted, which is equals to the initial number of moles minus the final number of moles. All of them, they are for what? For HBr. Now, take the metal carbonate. I took the metal carbonate and HBr. I did a ratio so that I get the number of moles of the metal carbonate. Now use those number of moles to get the molar mass of the metal carbonate using N is equals to mass over molar mass. Then I finally found what the molar mass of substance X is, and then I identified